So here are the correct answers from chapter 15 of what I've assigned to you. Starting with number 3, the expected value, which again turns out to be equal to mu, turns out to be 2.22. So again, that's an average. You're allowed to have that as not a whole number. For number 9, for part A, here's our lovely little chart. For part B, the expected value of mu is 1.176. For part C, you need a combination here of, again, the chart of not number of students called on, but wrong answers. Could get no wrong answers, or 1, or 2, or 3, or 4. Again, multiply those by the probabilities, so it turns out to be an expected 0.1785 wrong answers. For the carnival problem, again, our expected value here, you could net, if you got the balloon popped on the first start, 95 or 90, 85, 80, or you all 4 darts, you didn't win anything, you lost 20 bucks for playing the game. Again, by those probabilities, for part B, it's an average of 3.44 darts. Expected value of your net is you're going to win 1720. For number 12, again, a Venn diagram might be helpful here. The probability the horse wins both races is the product of 0.2, 0.3, 0.06. So that goes in the middle of the Venn diagram. So showing us that the probability that the horse will win neither is 0.56. So then the expected outcome, the profit here, will be $10,600. For number 19, again, you can fill out the chart yourself there. Number of repair calls averages out to be about 1.7 calls. For part B, again, the standard deviation is the square of the variance. Again, you can look through that. Take the square root of 0.81, turns out to be 0.9. For 22, for part A, the model here, the insurance company can make a profit of 100, or a loss of 9,090, or a loss of, 9,900, or a loss of 2,900. So the expected value of profit for the insurance company is $89 per policy. And as before, we're going to take the difference in each outcome minus mu, which you just figured out in part B, square it, multiply it by the probabilities, take the square root of 67,879 as approximately 260.54. For 25, the two games are not independent. Again, with the numbers they gave you, their probability that you win the second depends upon whether or not you win the first. You have a tough opponent. Part B, the probability of losing both games. Again, it's conditional. Probability of losing the first, 0.6. Probability of losing the second, given that you lost the first, was 0.7. The probability of winning both games, again, conditional, 0.4 times 0.2 will give you 0.08. You're not going to do that. And notice there with our probability model, there are only 3 outcomes. You lose both games, you win one game, or you win both games. Considering parts B and C, you figured out 2 out of those 3 probabilities. Oh, look, 0.24 plus 0.08 will give you 0.5. So the probability of winning one of the 2 games is 0.5. So then your expected outcome, multiply again with our chart, 0.66 games, and then a standard deviation of 0.62. For number 29, again, this is just dealing with the fact that when you multiply, that scale factor changes the mean and the standard deviation. So for part A, you multiply both of them by 3 and we're good. When you add, it only changes the mean. For part C, again, adding one to the other, simply add the means. But for the standard deviation, we have to take what they gave us as standard deviation for each of them, square it to turn it back into variation. Then you can add the variations, and then you got to take the square root to get it back down to standard deviation. So that's pretty much the same process for part D and for part E. Note there the difference there. Part D, the mean, you're subtracting those two random variables. You subtract the means. It doesn't matter if you're adding or subtracting. For standard deviation, you're always going to add. I'll say that again. For standard deviation, you're always going to add. And then for part E, hopefully you weren't too confused by this. Their notation there is basically adding the random variable x plus itself. So they're writing it out there as addition. 10 plus 10 is 20. Standard deviation, 4 plus 4, that'll give you 8. Square root of 8 of 2.83. Then for 36, just trying to apply those. So the probability, the expected value of how many good seeds you're going to get in 5 packets, multiply that by expected value of getting good seeds in 1 packet. 5 times 18 is 90. And again, take the standard deviations, square them, add them together, take the square root, back down to a standard deviation, 2.68. We're presuming that the packets of seeds are independent from one another. If you bought them all at the same store and they got a bad batch, I don't know, that assumption might be questionable. 43, how many tickets is the company going to have to pay here? Again, for the mean, we're just going to take the expected value tickets for 1 truck, multiply that by 18. And then for standard deviation, again, we're going to have to square the standard deviation, turn it into variance. Then we can multiply. Again, it's a scalar multiple here, so you do multiply the variance, just like you multiplied the mean, but then take the square root and get it back down to a standard deviation. And finally, for number 45, the standard deviation is large because, yeah, there's a whole bunch of policies, hopefully, where they make small gains. There are going to be a few where they've got to pay out a large amount, so it's a large loss. So yes, it's a big swing. The average from one to the next can vary greatly. So then part B, yes, the expected outcome here, if you only sell 2 policies, is an income of $300 with a standard deviation of, oh my goodness, 8,485.28. If they sell 10,000 policies, expected value is $1.5 million. And then standard deviation, again, square it, turn it into a variance, multiply by the, again, same scale factor, 10,000. Then take the square root back down to a standard deviation, 600,000. So yeah, the profitability went way up, but the standard deviation also increased significantly. Are they going to make a profit? Yeah, if they sell enough policies. And again, diversity is the key there. Don't sell them all in the same place because natural disaster, yeah, they're not going to do so well.